We are asked to solve this equation for all solutions in the interval from 0 to 2 pi. Now folks, very important on this interval. Because there's a bracket, the 0 is included, but because this is a parentheses, the 2 pi is not included. Okay, we have cosine 4x plus cosine 2x equals 0, so we're going to pull out our trigonometric function formula sheet, and we're going to use the sum and the difference formulas. This is a sum of two cosine functions. Now here, in this specific problem, we have an a value of 4x and a b value of 2x. Okay, so let's go ahead and plug in 4x for a and 2x for b. That's going to leave us with 2 cosine of 4x plus 2x here over 2 times cosine of the difference between them, 4x minus 2x over 2. And when we simplify, we're going to have 2 cosine of 6x over 2 times cosine of 2x over 2. We're going to simplify each of these fractions, and we're going to end up with 2 cosine 3x cosine x. And recall, originally this was set equal to 0. So let's go ahead and make some room, and let's take this simplified function and set it equal to 0. If we divide both sides by 2, then the 2 goes away. So folks, if you use the zero product property, that means we're going to have the cosine of 3x equals 0 and the cosine of x equals 0. And we're going to solve both of these equations, and we're going to include all the solutions for the solution of the original problem. Let's proceed with solving both of these factors set equal to 0. We have, let's do this one first. It's simpler. Cosine of x equals 0. That means the x coordinate on the unit circle is 0. So we're going to have pi over 2 here, obviously. This puts us in the world of 2's. In the world of 2's, instead of pi, we're going to multiply by 2 over 2, and pi becomes 2 pi over 2. Here, this is 1 pi over 2, 2 pi over 2 to get to pi. This is 3 pi over 2. So the solution for this part of the equation is pi over 2 and 3 pi over 2. Now, when we get to here, the argument is going to equal pi over 2 and 3 pi over 2. So let's look at this argument. Originally, we had the interval from 0 to 2 pi. That was for x. Okay, so let's put x in between 2 pi and 0. And again, we're going to include 0 with that greater than or equal to, but we're going to have a less than with 2 pi. Well, if you're looking at 3x, because that's the argument, you have to multiply all of this by 3. So now we're going to have 0, 3x in the middle, and is less than 6 pi. So instead of only going from 0 to 2 pi and getting these two solutions, we're going to have to go around and around again and go all the way to 6 pi. So that means we're going to have to set 3x equal to, here's pi over 2 and 3 pi over 2. Now folks, we're going to have to keep adding 2 pi to go around and around. All right. Now 2 pi in the world of 2's, here's 2 pi. To get into the world of 2's, we're going to multiply by 2 over 2, which is just 1, and we're going to get 4 pi over 2. So we're going to add 2 pi to pi over 2. That's a complete revolution. 2 pi is the same as 4 pi over 2. So that means this argument is going to be 5 pi over 2. When we add 4 pi over 2 to 3 pi over 2, we're going to get 7 pi over 2. Okay, but we still have not reached 6 pi. All right, the initial is from 0 to 2 pi, that's normal. Now we added 2 pi to everything, that's the interval 2 pi to 4 pi. Now we have to add 2 pi to each of these to get the interval 4 pi to 6 pi. We're going to do the same thing. We're still in the world of 2's. So we're going to add 4 pi over 2, otherwise known as 2 pi, to 5 pi over 2, and we're going to get 9 pi over 2. And then we're going to add 4 pi over 2 to 7 pi over 2 and get 11 pi over 2. Okay, folks, so now what we're going to do is we're going to set 3x, which is the argument, to each one of these. And then we're going to solve for x. Okay, so we've gone ahead and done that. We set 3x equal to pi over 2, 3 pi over 2, and then we extended. We added 2 pi, otherwise known as 4 pi over 2. We kept adding 4 pi over 2 to the original. We added 4 pi over 2 to pi over 2, we got 5 pi over 2. 4 pi over 2 to 3 pi over 2, we got 7 pi over 2. Then we went ahead and we added 4 pi over 2 to each of these. So we went to 5 pi over 2 to 9 pi over 2, 7 pi over 2 to 11 pi over 2. Okay, folks, we're going to solve for x for each of these. And that's going to involve multiplying both sides by 1/3. So you could see this first answer is going to become x equals pi over 6. The next one is going to be x equals 3 pi over 6, otherwise known as pi over 2. Then we're going to have x equals 5 pi over 6. Okay, that's down here, multiplying that by 1/3, that by 1/3. Continuing up here, we're going to have x equals 9 pi over 6, otherwise known as 3 pi over 2. Then we're going to have, finally, x equals 11 pi over 6. Okay, so what we're going to do now, folks, is we're going to eliminate the repeaters, and then we're going to list them from lowest to largest. Okay, during the break I realized that I left one of the answers off, and that's this one right here, 3x equals 7 pi over 2. So we're also going to have here, we'll squeeze it in, x equals 7 pi over 6. Okay, folks, if we eliminate all the repeaters, our final answer is as follows. We're in the world of 6's, so we're just going to take advantage of that. We're going to have pi over 6. Next is 3 pi over 6, otherwise known as pi over 2. Then we're at 5 pi over 6, 7 pi over 6, 9 pi over 6, otherwise known as 3 pi over 2, and finally 11 pi over 6. So if you look at this final solution set for x, you notice that all of these are within the range 0 to 2 pi, because 11 pi over 6 is 12 pi over 6 is 2 pi. Look at the intuition of this problem. So here we have the zero product property. Cosine of x equals 0. We know that x is going to be pi over 2 and 3 pi over 2. If you try to make x any bigger, you're going to be out of our zone here, out of our domain. But when you have 3x, don't forget, 3x, all we have to have is whatever that argument is equal to either pi over 2 or 3 pi over 2, and we get a cosine of value of 0. So the fact that that's 3 times x allows us to use smaller values of x. So as long as you multiply 3 times x and you land on pi over 2 or 3 pi over 2, we could use smaller values of x. So basically, we went ahead and we first set 3x equal to pi over 2, and we got x equals pi over 6. Then we set 3x equal to 3 pi over 2, and we ended up with 3 pi over 6, and we reduced that to pi over 2, so that became a repeater. But then we realized that we could set 3x equal to another revolution around the unit circle. So instead of setting 3x to pi over 2, we added 2 pi and set 3x to 5 pi over 2, because pi over 2 plus 2 pi is the same as pi over 2 plus 4 pi over 2, or 5 pi over 2. So when we set 3x equal to 5 pi over 2, x turned out to be 5 pi over 6, still within the range. So again, the fact that you're multiplying your x value by 3 means you can use smaller values of x, and there are more of them that will take you to either pi over 2 or 3 pi over 2, which is what you need in the argument to get 0. Folks, one of the best ways to get the intuition on this problem is to look at the graphs. So here we have y equals cosine x graphed. And recall, cosine x has a period of 2 pi, minimum and maximum of 1. There are no transformations here, so the period is going to stay at 2 pi. The amplitude is going to stay at 1, and there's no horizontal shift, so we're going to start at 0. Sinusoidal functions move by 1/4 of a period. So you could see here, if we take 2 pi and we multiply it by 1/4, we get 2 pi over 4, otherwise known as pi over 2. So folks, every pi over 2, something is going to happen. So here we go. We start out at the maximum for the cosine. 1/4 of a period later, we're at the middle. 1/4 of a period, we're at the minimum. Then the middle, then the maximum. So the whole idea when you graph sinusoidal functions or transformations thereof is to get it split up 1/4 of a period. Okay, let's now look at cosine of 3x. Okay, here we go. This is a transformation. The amplitude doesn't change right here. The middle of the graph doesn't change because there's no horizontal shift up. There's no translation horizontally, but there is a change in the period. And recall, the way to get the period of a transformed function is to take the original function, period, which in this case is 2 pi, and divide it by the b value, which in this case is 3. So the period is going to be 2 pi over 3. Now, as before, we're going to take that period and we're going to divide it into fourths. We're going to end up with 2 pi over 12, otherwise known as pi over 6. Okay, so we're going to march along by pi over 6. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Let's keep going. 5 pi over 6, 6 pi over 6, 7 pi, 8 pi, 9 pi, 10, 11, and 12. Now, why did I stop here? Because, folks, that's none other than 2 pi. And the original problem wanted us to find all the x values where the cosine of 3x is 0 between this interval of 0 to 2 pi. Now, when you do this, it's very easy to set it up here by marching, excuse me, by pi over 6. But some teachers don't let you get away with this. So at the very end, no problem, you just reduce all these. So at the very end of the problem, you can erase this, change that to 2 pi over 3, change that to pi over 2, change that to pi, etc. Okay, so let's now go ahead and graph our function, cosine of 3x. The period for this function is going to stop at 2 pi over 3. So here we go. No horizontal shift, so we're going to start at the maximum. We're going to go to the middle, to the minimum, to the middle, and back to the maximum. So folks, this is one period of cosine of 3x. So you could see, here's the period, 2 pi over 3. But folks, look, we have plenty of x values left here. So we're not going to stop here. We're going to keep going. So let's do that. Maximum, middle, minimum, middle, maximum, middle, minimum, middle, maximum. Okay, folks, here is our entire graph from 0 all the way to 2 pi. Look how many x values we have that cross where y equals 0. Look how many x-intercepts we have. Okay, and in fact, those ended up being our final answers. Pi over 6, 3 pi over 6, otherwise known as pi over 2, 5 pi over 6, 7 pi over 6, 9 pi over 6, which again, you can reduce that, 11 pi over 6, and that's it. To reduce 9 pi over 6, the way I like to reduce fractions is to break them down. So this becomes 3 times 3, this is 3 times 2, 3 over 3 is 1, so this becomes 3 pi over 2. Let's now look at a similar problem, namely cosine of x over 2 equals 0, again with the solutions limited to this interval. So the x values are limited from 0 to 2 pi. Folks, we know that this argument has to land on pi over 2 or 3 pi over 2. All right, so let's look at what happens when x over 2 has to be within the specific range. So here we go. If x has to be between 0 and 2 pi, then if we multiply everything by 1/2, we see that x over 2 has to be between 0 and pi. Therefore, we can set x over 2 equal to pi over 2, because we're trying to land on pi over 2 and 3 pi over 2. So if we set x over 2 equal to pi over 2 and we pattern match, we see that our x value equals pi. However, if we try to set x over 2 equal to 3 pi over 2, that violates this interval. We're not allowed to set x over 2 equal to 3 pi over 2, because 3 pi over 2 is greater than pi. Look, here's pi right there, so we're only limited to this interval that we can set x over 2 to. So here, we are not allowed to do this. So the only solution for this particular equation, when we have x over 2, is pi. There's no better way to get the intuition than graphing it. We want to know where cosine of x over 2 equals 0 during the interval from 0 to 2 pi, where 0 is included and 2 pi is not. So we're going to change x over 2 to 1/2 x. Our b value is 1/2. We're going to take the normal period, which is 2 pi, divide by the b value, and we find that the period is going to be 4 pi. And that makes sense because this function that we're looking at is half as fast as the normal function, cosine. Our period is 4 pi. Always divide your period into 1/4 aliquots. You multiply by 1/4, you get pi. That means we're going to march by pi. 1 pi, 2 pi, 3 pi, 4 pi. That's when things happen over 1/4 of a period sections. Okay, here, cosine starts at a max of 1. Again, here in this function, there is no vertical shift, there's no horizontal shift. From the maximum, we go to the middle, to the minimum, to the middle, to the maximum. Here is our graph. They want to know, where does this graph equal 0? What are the y values? Where it equals 0? Well, here we go. We have pi and 3 pi. The problem is that 3 pi is out of the range that we're limited to. Therefore, the only result, the only solution of this problem is pi.